I see this pattern way too often when working with SOD or any schema validation library really, where you have an entity, for example ToDoSchema, and this is an object, has 3 properties, and then you need this as an array. So you just say set.array ToDoSchema and you're good to go. Seems simple enough, right? Well, there's a major problem that will bite you and your users down the road. And that is, if a single item in this array fails validation, then everything will fail. So here's what I mean. Let's say we have an API response and this item right here is malformed. So ID is a string, title is null instead of a string. Now if you run this code, instead of getting the 2 valid to-dos, everything will fail. Now this is very painful when you're dealing with third-party APIs that might be, let's say, inconsistent, which is far too common, or your backend team decided to modify a property without proper migrations or versioning, which is also far too common. So instead of crashing down the whole application and damaging a feature in its entirety, well, you probably shouldn't be doing this. So what do I recommend instead? Well, for this I'm going to be using Effect, but you can apply this to SOD, to Yup, to Valipod, to whatever validation library you're using. Now I prefer Effect Schema because it is the next evolution of validation libraries. All validation libraries like SOD focus just on validating unknown and transforming the data into T being the structure you define. For example, this object right here. Meanwhile, Effect Schema focuses on bidirectional parsing. So you can go from the from to the to, and then the to the from. So for example, from a JSON to a structure, and then the structure back to the JSON. Now this is just an example, but obviously the structures can be way more complex. And this is particularly useful for when you want to deal with validation forms in the front end. You receive a date object, but the backend expects the data as a string, or you need to store data in the database, you need to serialize and deserialize, and so on and so forth. It has a ton of utilities. So this is why I'm going to do everything with Effect Schema, but again, you can translate this easily over to, say, SOD. So what do we do here? Well, we have an ArrayFromFallible, which is just an extension to schema.array, where what we do is define that it is going to be an array of the schema we pass in with a union of null. So null or the schema we pass in. That way, we can add a decoding fallback, which means that this will be triggered when this validation fails. And here, we just recover or succeed with null. That way, we are now inherently omitting any element that comes in a malformed state. And then once we do this, we do a transformation into what? Well, just a schema.array of the schema. So no union with null. And that's it. When decoding it, we filter those that are not null, and when encoding it, well, we just preserve the array as is, because we know that when encoding it, we are receiving this, and not this one right here. So to recap, what we're defining is an array of what? Of T or null, and then we filter where is not null, so we just get the array of T. And in the process, the idea is to log this information in the console. So in the case we omit an item, you can simply check your logs and see what went wrong. So now to use it, all you need to do is define your structure, and then you can say ToDoSchema is equal to ArrayFromFallible, and then you pass in the schema. And now you have your API response, which is malformed, and we can confirm this at the compilation level by using decodeSync. And as we can see, we get a type error here saying a string is not assignable to type number. And if we run this code, we should get this log, so from ArrayFromFallible, where to do or null, to do at ID, expected number, actual to, and finally we should get the two to-dos that are not malformed. So if I run this, as you can see, we get the log here, the warning, and then we get the array, filtering the one with ID 2, as we can see here, and that's it. Now, the great thing about doing this at the schema level is that you can have nested arrays and they will all be decoded gracefully. So, same example, we have the to-do schema, we have the user schema, and the to-dos is ArrayFromFallible, and then the user's schema is ArrayFromFallible. So we have this to-dos property nested. And if we have this API response, where for the first one we have malformed data, for the second one it's okay, and the third one, the user entity itself, is also malformed, then once we run this, as you can see, we get the warnings here, where one is for the to-do, the other one is for the user itself. As we can see, for the first user, we filtered out the malformed to-do, and then, as we can see, there is no Jane in the users list. So as we can see, it works as intended. Now, one last thing is I would recommend having a decoder like decodeUnknownPartition, where it is going to return to you a tuple, where the first element is the array of errors, and then the second element is the array of succeeding values. That way, when you need to decode an array and you do not want to omit each one, but instead be able to map over the failure ones and map over the succeeding ones for logging, for whatever, then I highly recommend having this utility, where you simply do a reduce, you decode every single item one by one sequentially, and then you match. If you get an error, we'll just append to the first element, and if it succeeds, append to the second element, and that's it. Now, all you need to do is say decodeUnknownPartition, you pass in the schema, and then you pass in self the data you want to decode, and it is going to collect everything nicely for you. And now when you run this, you're going to get them partitioned. So I highly recommend creating a utility like this as well. Anyway, this wraps up the video. If you want to see more content like this, make sure to subscribe. I'll see you in the next one.